Hello everyone, welcome to our presentation on content-based recommendation systems. We see recommendations every day today. Netflix suggesting the next movie, Spotify creating personalized playlists, and shopping apps showing items similar to what we browsed. But how do these systems actually figure out our taste? That's where content-based recommendation systems or CBRS come in. In this presentation, we'll walk through three main ideas: how the system learns about you, how it learns about the content of items, how it matches the two using similarity. By the end, you'll understand not just how recommendations are generated, but also the strengths and limitations of this approach. Let's begin with the core intuition. The foundation of a content based system is very straightforward. It recommends items that are similar to what you liked before. For example, imagine you've been watching a lot of sci fi movies. The system identifies patterns from your history, such as space, future technology, AI, and adventure. Then it searches for new movies that share those same characteristics. Unlike collaborative filtering, which uses the opinions of many other users, content based systems depend only on your own behavior and the attributes of those items. This makes them highly personalized and independent of any other users.
Moving on to building a user profile. So to generate meaningful recommendations, the system first builds a user profile. Think of this as a digital summary of your interests. The profile is constructed using two main factors, one of which is implicit feedback like watch time, clicks, scrolling, and reading duration. And the second factor is explicit feedback such as ratings, likes, or favorites. Let's take an example. If a user consistently reads research papers about neural networks and reinforcement learning, those keywords will get higher weights in the profile. And if they also get a little on the computer vision, that will get a moderate weight. The user profile eventually becomes a vector, meaning a numerical representation of all the topics, genres, or the features the user prefers. This vector becomes the reference point for recommendation. Next, we have item feature extraction. So just by knowing the user's interest, it isn't enough. The system must also understand what each item contains. This part is called item feature extraction. Depending on the content type, features may come from different sources. Like we have text, which is movie descriptions, article titles, keywords, and tags. Then we have metadata, which consists of genres, categories, authors, and publication year, followed by visual content by using CNNs to analyze images or thumbnails. So to convert text into numerical data, two common techniques are used. First one is TF-IDF, which stands for Term Frequency Inverse Document Frequency. This technique highlights the most important words in a document, followed up with the second technique, which is word embeddings, such as word to vec or BERT, which capture the meaning and the context. For example, in a movie metadata, action, adventure, and thriller may be the features, but in a research paper, there might be different features like topics, author names, or frequently occurring technical terms. Once these features are extracted, every item will become a vector similar to those like the user vector. So matching the items using cosine similarity. Since we have both the user and the item vectors ready, the system needs to know how to measure these vectors and how close they are in similarity. So this is where cosine similarity comes in. Cosine similarity measures the angle between two vectors. If there is a smaller angle, it means there is a higher similarity, whereas if the angle is large, that means there is lower similarity. For example, if a user profile heavily emphasizes science fiction and an item vector also has a strong sci-fi features, the similarity will be high. This makes cosine similarity ideal for high dimensional text data where document lengths vary widely. Finally, the system will compute similarity for all the items and pick the top matches.
Also, content-based systems offer several important advantages. Firstly, they are highly personalized because they depend entirely on your own history. Next is they work very well for new items since as long as features can be extracted, the system can recommend them immediately. And finally, we have explainability. That is like we can point to exactly which content features influence the recommendation, like genre, keywords, or tags. However, they also have a weakness when it comes to new users, which is known as cold start problem for users. Like for example, if someone just joined the platform and has not interacted with anything yet, the system has no basis for building the profile. That's why many apps ask you to pick interest or favorite genres when you first sign up. It helps the system build an initial profile. Now, one of the most significant drawbacks of content based systems is over specialization. Because the system focuses only on what the user has already liked, it can unintentionally trap users in a filter bubble. If someone only explores action movies, the system continues recommending more action movies, rarely providing something outside that comfort zone. This reduces serendipity, which is the chance of discovering something new, surprising, and potentially interesting. Platforms often use hybrid systems to overcome this issue and introduce more variety into recommendations. So, to conclude, content based recommendation systems are a crucial part of modern digital platforms. They learn your preferences, analyze the content of items, and use similarity measures to deliver highly personalized results. Their ability to recommend new items immediately and explain their decisions makes them very powerful. However, over specialization and cold start for new users remain challenges. Thank you for watching our presentation. We hope this gave you a clear and practical understanding of how content based recommendation systems work.